Hello, good morning everyone. Welcome to Guru Brahma classes for JEE and NEET. We are in the chapter Ionic Equilibrium. In this session, we are going to solve some problems on ionization of weak acid. Ionization of a weak acid. So let us solve. Let's start the session. So here given in the case of a weak acid. What is that? In the case of a weak acid. So in the case of weak acid, already we have discussed some things. Weak acid. In the case of weak acid, we have discussed that Ka is equal to C alpha square, where the acid is very weak acid, where alpha is very much less than 1. So 1 minus alpha is almost equal to 1. So this is the condition. Ka is equal to C alpha square. What is alpha? You know, alpha is degree of dissociation. Now what you get? Alpha is equal to root Ka by C. Okay. And for weak acid, we have studied that H plus ion concentration at equilibrium is equal to C alpha, and that is equal to C into root Ka by C, because alpha we have already derived that it is root Ka by C, and C will be equal to what? This H plus ion concentration will be equal to C into root Ka by C, and which is equal to root Ka. What is that? Root Ka into C. Root Ka into C. This is H plus ion concentration at equilibrium. And we have also derived a formula. You know the formula pH is equal to half pKa minus half log C. So this is the formula to calculate the pH of a weak acid. So these formulas were already derived in the concept or in the lecture where we have discussed regarding the ionization of a weak acid. So based on these formula, there are some problems we need to solve. So let us solve them. Let's start. So question number 1. So what is given? What is asked? Let us see that. A weak acid is 0.01% ionized. So what is this 0.01%? That is called as what? Alpha percent. Alpha percentage is equal to 0.01%. Okay. But what is asked? Ionized in 0.1 m solution, its ionization constant is asked. So what is ionization constant formula? Now only we have seen Ka is equal to C alpha square. We want alpha, we don't want alpha percentage. So what you need to do? You have to find alpha. Alpha is equal to alpha percentage by 100. Then that is equal to alpha percentage is given as 0.01 by 100. That is equal to 10 power minus 2 by 10 power 2, and that is equal to 10 power minus 4. Okay. So alpha we got it as 10 power minus 4, and C given. C how much given? 0.1 molar. So 0.1 molar, and that is equal to 10 power minus 1 molar. So let us substitute this C and alpha in this equation. So Ka is equal to C is 10 power minus 1 into alpha is given as 10 power minus 4 whole square. And that is equal to 10 power minus 1 into 10 power minus 8 is equal to 10 power minus 9. Okay. So what answer did we get? 10 power minus 9. So that's the answer. Where is the answer? Yeah. Ka. Right? Understood? The next question, let us see. The dissociation constant of a weak monobasic acid in 0 point. Dissociation constant of a weak monobasic acid actually. So concentration given. What is the concentration given? 0.01 m, which is equal to 10 power minus 2 m. And dissociation constant is given as Ka is given as 10 power minus 8. So what is OH minus ion concentration? What is asked? OH minus ion concentration. Okay, and we know that for a weak acid, for a weak acid, for a weak acid at equilibrium, H plus ion concentration at equilibrium is equal to C alpha. Okay, so and C into alpha is equal to, you can write it as Ka by C, which is equal to root Ka into C, because alpha is equal to root Ka by C. This already we know. So H plus ion concentration. So H plus ion concentration is equal to Ka, how much given? 10 power minus 8 into how much C given? 10 power minus 2 whole power 1 by 2 H plus ion concentration. So which is equal to 10 power minus 10 whole power 1 by 2, 2 fives. Okay. So how much did we get? 10 power minus 5 molar. And we know that at 25 degrees centigrade. Why we are taking 25 degrees centigrade? Because temperature is not mentioned. When it is not mentioned, compulsorily we have to take standard temperature, room temperature. What is that? 25 degrees centigrade. And we know that H plus ion concentration into OH minus ion concentration is equal to 10 power minus 14 molar square. And here he is asked as OH minus ion concentration. OH minus ion concentration is equal to 10 power minus 14 molar square by H plus ion concentration, and that is equal to 10 power minus 14 molar square. How much did we find H plus ion concentration? 10 power minus 5 molar. Okay, then OH minus ion concentration, what did you find? You have found that it is equal to 10 power minus 9 at molar. So where is the answer? 10 power minus 9 molar, right? So that's the answer. So let us go with the next question. So what is given for this question? What is given? Let us, question number 3. A monobasic acid solution, pH value is equal to 5. So pH is equal to 5. If pH is given, then what will be H plus ion concentration? We know that if pH is given, H plus ion concentration is equal to 10 power minus pH, and that is equal to 10 power minus 5 molar. So we know H plus ion concentration. And what is given? pH is equal to 5. Its molarity is 0.005 m. So concentration is given as 0.005 m, which is equal to 5 into what is that? 5 into 10 power minus 3. 5 into 10 power minus 3 molar, right? So concentration given, H plus ion concentration given. So we know that for a weak acid, we know that H plus ion concentration is equal to C alpha. So you are asked about degree of the ionization of acid. So we want alpha. So alpha is equal to H plus ion concentration by C, which is equal to H plus ion concentration given as we have derived it as 10 power minus 5 molar, and concentration is 5 into 10 power minus 3 molar. Then what you get is I can write this as 10 into 10 power minus 6 into 10 power plus 3 by 5. So that is equal to 2 into, okay, 10 power plus 3 alpha. So do we have that option? 2 into 10 power 2 into 10 power minus 3. We don't. What is that answer? 2 into 10 power minus 3. Minus 6 plus 3 minus 3, right? So this is the answer. Okay. So 1 liter of water. So what is given? What is given here? 1 liter of water. This is 1 liter of water. So let us take how much? Volume is equal to 1 liter. That is equal to how many ml? 1000 ml. And we know that density of water is equal to 1 gram per ml at 4 degrees centigrade. Okay, but actually in normal temperature also we general consider it as 1 gram per ml. So in JE means like question they will give here like density of water is equal to 1 gram per 1 ml in this way they will give. Okay, and that means 1000 ml weighs how much? 1000 ml of water weighs how much? 1 gram, 1 ml weighs 1 gram. So 1000 ml weighs how much? 1000 grams, right? So this 1 liter water is taken. 1 liter of water contains 10 power minus 7 moles of how much? 10 power H plus ion concentration given 10 power minus 7 molar. That means moles per liter. What is that? Moles per liter. Per 1 liter, how many moles are there? 10 power minus 7. How much H plus ions? Degree of ionization of water is. So what is asked? Alpha is asked. Alpha is asked. And we know that here water is dissociating into water dissociates into H plus and OH minus. At temperature T is equal to time T is equal to 0, let the concentration of water be C. Concentration of H plus and OH be 0, 0. And you know that as it is a reversible, as water is a weak electrolyte, there will be forward reaction and backward reaction, and there will be an equilibrium existing between dissociated ions of water and undissociated water molecule. That means at equilibrium, at equilibrium time, let C alpha be degree of dissociation. Okay, and we know that 1 mole of water on dissociation gives 1 mole of H plus and 1 mole of OH minus. So if C alpha is dissociated, how much H plus will be formed? C alpha, OH minus is formed C alpha. And how much H2O will be present? C minus C alpha. So what is H plus ion concentration at equilibrium? We call it as, we take it as H alpha. And alpha is equal to what? H plus ion concentration by C. So what is the concentration of water? What is the concentration of water? How to calculate concentration of water? See, concentration of water. We calculated it in the terms of molarity. And we know that molarity is equal to number of moles by volume expressed in liters. That means 1 liter of water, let us take. Weight by molecular weight by volume expressed in liters. So how much volume we took? 1 liter volume we took. In 1 liter volume, how many grams are there? 1000 grams. 1000 grams by, what is the molecular weight of water? 18. So molarity, what do you get? Okay. What do you get? We get 1000 by 18 is equal to 55.555. We can take 55.56 molar. How much we are taking? 55.56 molar. So then now calculate alpha. Alpha is equal to H plus ion concentration given as 10 power minus 7. So 10 power minus 7 molar by, here what is the concentration? C. What is C here? Concentration of water. Concentration of water, we have calculated it as a 55.56 molar. So calculate it. Then I can write it as 100 into 10 power minus 7 molar already got cancelled by how much? By 55.56. Then what do you get? 100 by 55.56 gives you 1.8 into 10 power minus 7. Okay, so minus 7, how much of minus 7 or minus 9? You will get it as minus 9. Okay, minus 9. So what did we get? We got alpha. So alpha is equal to, how much did we get? 1.8 into 10 power minus 9. But what is asked in percentage? What is asked in percentage? So alpha percentage. Alpha percentage is equal to alpha into 100 gives you alpha percentage. That means 1.8 into 10 power minus 9 into 100. So what do you get? 1.8 into 10 power minus 7. So this is what alpha percentage. How much did we get? 1.8 into 10 power minus 7. So where is that 1.8 into 10 power minus 7? Here is the answer. Understood? Understood? Right? So let us see the next question. So here what is given? We are speaking about relative strengths of acids. Relative strength of acid. Already we have discussed about strong acid and weak acid. Already previously we have discussed that what is strong acid, how do you decide whether an acid is strong or weak? It depends upon its degree of dissociation. So strength of acid depends upon its degree of dissociation. So strength of an acid depends on, we say, degree of dissociation. Degree of dissociation. One of the factor which decides the strength of an acid is degree of dissociation. What is that? Alpha. So we know that strong acid, for strong acid, alpha is equal to 1 or alpha percentage is equal to 100%. Weak acid is alpha less than 1, we say. Okay. So alpha percentage less than 100%. General condition. Okay. So that means on what factor does the strength of an acid is depending? One of the factor which decides the strength of an acid is degree of dissociation. More the alpha, more the strength of the acid. What we can say, more the alpha, more the strength of acid. More the strength of an acid. So when two acids are given, then one of the factor which decides the strength of those two acids is alpha. The acid which is having more alpha will be having more strength than the acid which is having less alpha. Okay, the one which more dissociates, that acid will be stronger. And we have studied that this is all for weak acids. So for weak acid, Ka is equal to C alpha square. Okay, for weak acids, very weak acids especially, what we know, Ka is equal to C alpha square. And alpha is equal to, then what you can write from Ka is equal to C alpha square. Then alpha is equal to, what you can write, root Ka by C. Okay, so for two acids, if two acids are given with the dissociation constant Ka1 and Ka2 at the same concentration C. So let alpha 1 will, this is two acids, acid 1 and this is acid 2. Acid 2. For acid 1, alpha 1 is equal to root Ka 1 by C. Alpha 2 is equal to root Ka2 by C. Why did we take both C? Because it is given same concentration. Both are having same concentration. So then what you write, alpha 1 by alpha 2? Alpha 1 by alpha 2 is equal to root Ka1 by C by root Ka2 by C. So root C gets cancelled. Then what do you get? Root Ka1 by Ka2. Root Ka1 by Ka2. So this ratio gives you the strength of the ratio of the strength of the acids. The ratio of the strength of the acids. Already we have discussed that alpha is one of the factor which decides the strength of the acid. Degree of dissociation is one of the factor which decides the strength of the acid. More the degree of dissociation, more the strength of the acid. Especially for weak acids, the ratio, if two acids are given and the ratio of their degree of dissociation gives you the ratio of their strengths. The ratio of their strengths. Okay. And that is one of the factor which decides the strength of a weak acid. And other factor is for a weak acid. Let us take for a weak acid. For an acid. Okay. So HA gives rise to H plus plus A minus. Then what will you write? Ka, equilibrium constant or dissociation constant of acid. We write it as H plus ion concentration into A minus ion concentration by HA concentration. HA concentration. Okay. If Ka is more, are you getting this? When Ka is more, when Ka is more, then what does that represent? H plus ion concentration and A minus concentration are more, and HA concentration is less. Is it correct or not? What does this Ka more represents? Numerator more, denominator less. That means H plus ion concentration more and A minus concentration is more and HA concentration is less. What does that represent? That represents that the reaction is more in the forward direction. What we can say that reaction is more in forward direction. Reaction is more in forward direction. That means, what does that mean? More HA is dissociated. More HA is dissociated into H plus and A minus. More it is dissociating means, more the dissociation means more the alpha. More the dissociation, we say more the alpha. More the alpha, we say strong the acid. Strong the acid. Okay. So this is for a weak acid. We are speaking about weak acid. For a weak acid, for this weak acid, Ka is written in this way. What does more Ka represent? More Ka represent more number of H plus and more number of A minus and less number of HA. That means more H plus concentration, more A minus concentration and less HA concentration. Okay. More H plus and more A minus means more HA is dissociated. More HA is dissociated means more the alpha. More alpha means stronger the acid. Stronger the acid. Stronger means among this weak acid only, but more the alpha, more stronger the acid. Relative. We can say stronger the acid. Stronger the acid. Not strong acid. Stronger the acid. Relative thing. When you are comparing with others, when you are comparing with other acid, that will be more stronger. Okay. So what did we understand? We understood that more the Ka, stronger the acid, less the Ka, less stronger the acid. Okay. So compare it. This is all comparison. What we are speaking about comparison. more the Ka value, stronger the acid, less the Ka value of an acid, then what do you say? Less stronger is the acid. Less stronger or weaker the acid. You can also speak about weak the acid. Weaker the acid. Okay. So by looking at Ka also, we can decide whether it is strong acid or weak acid. Before we have discussed one of the factor which decides the strength of the acid. What is that? Alpha. More the alpha, more stronger the acid. Another factor which decides the strength of the acid is Ka. What is that? More the Ka, more stronger the acid, less the Ka, weaker the acid. Understood? And another factor, let us see, another factor which decides whether which is stronger, let us see. pKa. So let us take Ka. Ka is equal to 10 power minus 3. Another acid, this is acid A, what we are taking, acid 1. Another acid, what we have taken, acid 2. Ka is equal to 10 power minus 5. Which acid is stronger? Acid, this is acid 1, this is acid 2. Both are weaker. Both are weaker. Now, acid 1 is stronger than acid 2. Right? Why? Because acid 1 has Ka 10 power minus 3. Acid 2 has Ka 10 power minus 5. Which is greater? Whether 10 power minus 3 is greater or 10 power minus 5 is greater? 10 power minus 3 is greater than 10 power minus 5. 10 power minus 3 is greater than 10 power minus 5. So I can write Ka1, Ka2. We know that Ka1 is greater than Ka2. Let us calculate pKa1. We know that pKa is equal to minus log Ka. pKa1 is equal to minus log Ka1, that is equal to minus log Ka1 is 10 power minus 3, that is equal to, okay, another step also we shall write. What is that? Minus of minus 3 log 10. Log 10 base 10 is equal to 1. Then what did we get? Plus 3. Here let us write pKa2. So pKa2 is equal to minus log Ka2, which is equal to minus log 10 power minus 5. That is equal to minus of minus 5 log 10 base 10. That is equal to plus 5. Okay. So more the Ka value, less the pKa value. Less the Ka value, more the pKa value. Okay. So from this, what did we understand is, okay, Ka is inversely proportional to pKa. That means we can write more the Ka value, stronger the acid. That means less the pKa value, stronger the acid. Stronger the acid. Because Ka and pKa are inversely proportional. From this data, what we have seen, we have found that if Ka is more, pKa will be less comparatively. If Ka is less, pKa will be more. So those two are inversely proportional. As those two are inversely proportional, here we have studied that more the Ka value, stronger the acid. In the same way, we say that less the pKa value, stronger the acid. Because more the Ka value means less the pKa value now. Here we have seen less the Ka value, weaker the acid. Then from that I can write that more the pKa value, okay, weaker the acid. Weaker the acid. Okay. So cumulatively we can say that more the alpha, stronger the acid, less the alpha, weaker the acid. More the Ka value, stronger the acid, less the Ka value, weaker the acid. More the pKa value, weaker the acid, less the pKa value, stronger the acid. Understood? So these three factors deciding by looking at these three factors, we can say that whether it is strong acid or weak acid. Comparatively, we are all speaking about comparatively whether it is stronger or weaker can be known by its alpha, its Ka and its pKa. Okay, so let us see the question. Let us see the dissociation constants of two acids Ha1 and Ha2. So two acids are given. Okay, so two acids Ha1 and Ha2. Ka1 is given. What is that? Ka1 is equal to 4.5 into 10 power minus 4. Ka2 is given for this. What is that? 1.8 into 10 power minus 5. If both are having equal concentrations, here concentration of Ha1 acid is equal to C. This is also C. Then what is the relative strengths? Before we have derived a formula. What is that? Alpha 1 by alpha 2 is equal to root Ka1 by Ka2. When is this formula? When concentrations, when C is same for both acids. For both acids. Okay. Then calculate it is alpha 1 by alpha 2 is equal to Ka1 how much given? 4.5 into 10 power minus 4 by 1.8 into 10 power minus 5. This is equal to, then what do you get? Root 4.5 into 10 by 1.8. That is equal to root 450 by 1.8. Sorry, root 45, right? And that is equal to root 25 by 1. That is equal to 5 by 1. So 5 is to 1. Okay, understood? So the strength of the acid is highest in. So now only we have discussed by looking at some factors like alpha, Ka and pKa, we can say which is stronger, relatively which is stronger. So here Ka is given. We have we know that more the Ka, less the pKa, stronger the acid. Stronger the acid. Other one is less the Ka, okay, more the pKa, weaker the acid. weaker the acid. Okay, relatively. Now highest, question asked is highest. Highest means Ka and pKa we have to look into. Let us all convert into either pKa or Ka. Let us convert it into Ka. Here it is given Ka. Okay. First option, let us go with the first option. In first option, what is given? And we know that Ka is equal to minus log, okay, pKa is equal to minus log Ka, and Ka is equal to 10 power minus pKa. So Ka is equal to 10 power minus how much given pKa? 6, 10 power minus 6. So this is first option. Second option, let us take Ka is equal to 10 power minus pKa, which is equal to 10 power minus 5 Ka. So third option, let us take Ka is equal to 10 power minus pKa, which is equal to 10 power minus 10 Ka. Okay. Ka is equal to 10 power minus 10. Fourth one given, already Ka given directly, 10 power minus 11. So among these four, 10 power minus 6, is that a 10 power minus 6, 10 power minus 5, 10 power minus 10, and 10 power minus 11. Which one is greater? Because more the Ka, stronger the acid. More the Ka, stronger the acid. Which is greater? 10 power minus 5 is greater. So the answer will be this. And we have studied that less the pKa, stronger the acid. Among these, pKa is less for this. Okay. More the Ka, stronger the acid. For the second option, Ka is 10 power minus 5. It is found to be larger than the remaining. So that will be the answer. Right? Let us go with the next. For the strong acid, okay, for the strong acid, we studied that for strong acid, okay, comparatively, what first one, alpha is high, more. Second one, Ka is high or more. Third one, pKa is less. This is for stronger acid. For weaker acid, first one is alpha is low, less. Second, Ka is less. Third, pKa is high. Okay. So now strong acid degree of dissociation is very high. It's correct. Ka is very high. Yes, correct. pK is very low. Correct. So answer will be fourth option. Answer will be what? Fourth option. Okay. Next question. Which of the following is relatively stronger acid? Ka values are given. When Ka values are given, we know that more the Ka value, right? More the Ka value, stronger the acid. And what is that? Stronger the acid. More the Ka value, stronger the acid. Among these, which is stronger? Ka values are given. Okay. So Ka of which is greater? Ka values, if you write Ka is equal to 10 power minus 2. So which is greater? 3. 1 into 10 power minus 2 is greater than, right? 1.8 into 10 power minus 3 is greater than, 3 into 10 power minus 5 is greater than 9.6 into 10 power minus 10. That means 3 acid 3 is greater than, acid 3 is stronger than, okay, acid 3 is stronger than 2, acid 2 is stronger than what one, acid 1 is stronger than 2, acid 2 is stronger than 4. So stronger acid will be what? Third. Okay. So looking at alpha, looking at Ka value, looking at pKa value, we can say relatively which acid is stronger, relatively which acid is weaker. Understood? So that is some basic questions we have discussed regarding ionization of a weak acid from the chapter Ionic Equilibrium. Thanks for watching. Let us meet in the next lecture or in the next class with a new topic, right? Thank you.